In this video, we'll talk about the while loop, another looping structure that allows for us to repeat a process. So a while-when loop is when all statements between the while and the when are repeated each time the loop is executed. The execution continues as long as the expression following the while remains true. The while loop is best used when you do not know the number of iterations that the program should perform versus the for loop. We usually knew the number of iterations that we wanted to execute. We need a loop initializing value that has to be declared at the beginning so the test condition is already true. Otherwise, the body of the loop may never execute. The while loop is a pretest structure like the for loop, so it may never execute if the initializing value isn't true for the test itself. So here we have an example of a while loop. So here we have the keyword while, and then when is what's used to close it, where we used for to open up the other looping structure, and next to at the end of it, we use while and when. And so we do need to have an initializing conditional value. In this case, it's based on choice equaling uppercase Y. So while choice is equal to uppercase Y, it will execute the body of the loop. If I forget to include line 40, then the body of the loop won't ever execute because the condition will be false at onset. So again, it's going to pretest to see whether or not it should execute. And as long as this condition is true, it will continue to loop through the body of the program. So while choice is yes, it will do that, which means that we have to make sure that our conditional test, though, eventually becomes false so that we can terminate the looping structure to move on through the program or to terminate the program. So we do need to have a condition changer. It was already built into the for loop. Every time I said next X, it was incrementing to get that value from 1 to 5, but I need to include that incrementer or that condition changer within the body of the loop for that to happen. It's not already built into the structure. So let's take a look at that same hello world program that we had with the for loop. Here we initialize count to equal 1. So while count is less than or equal to 5 is the condition. Well, 1 is less than or equal to 5, and so therefore it is going to print hello world to the screen. Okay, so we have our loop initializer, we have our loop controller, and then we have to have an incrementer. So it's going to print hello world to the screen, but I need to increment count to the next value so that eventually this count will no longer be less than or equal to 5 and it terminates. Okay, so what it does here is it's going to take count and it's going to take the current value stored in count, which is 1, and add 1 to it. We use this incrementing value in the last lesson. And so count becomes equal to 2. Okay, and so 2 is less than or equal to 5, so it printed hello world again. And so then it's going to take the current value of count, which is 2, and it's going to add 1 to it, so count's going to equal 3. 3 is less than or equal to 5, so it printed hello world to the screen. It's going to take that 3, add 1 to it, so count's equal to 4. 4 is less than or equal to 5, so it prints hello world to the screen. It's going to take that 4, add 1 to it, so count's equal to 5. 5 is less than or equal to 5, so it's going to print hello world to the screen. It's going to take that 5 and it's going to add 1 to it, so count's equal to 6. Well, 6 is not less than or equal to 5, so this is going to be a false statement, so it's going to terminate at that point and then fall out beyond line 50 of the looping structure. In this case, it stops printing hello world to the screen. So I could do the same iterative algorithm in a while loop that I did in a for loop. They're actually interchangeable. There's always a better choice. So the while loop is best used when I don't know the number of iterations, where the for loop is best used when I know the number of iterations. I can also nest while loops, like I nested my for loops. So here's an example of using it and waiting for the user to change it, in this case using the string. So we let choice equal uppercase Y. So while choice is equal to uppercase Y, it asks the user to input what is your guess. So they enter a number. If guess is equal to 7, then print this is your lucky day. Otherwise it prints better luck next time. It asks the user to input, would you like to try again? So the idea here is while choice is equal to uppercase Y, the body of this loop will continue to execute. So, you know, some of the programs that we've run up to this point, it would have been really nice if I could run them over and over and over again. So I can encase, you know, an old project that maybe took up this much space, you know, in my program, I can encase it by a while when loop and have it execute over and over and over again until the user decides they no longer want to run the program. So the for loop and the while loop are interchangeable looping structures. We choose one over the other based on whether or not we know the number of iterations, but even that should not be the only reason why I choose it. But those are usually what indicates me to use a while loop over, you know, a for loop, with the idea that, you know, while I want to do something, I'll do it. But once I no longer want to do it, then it will terminate. Where the for loop tends to go from, you know, one value to another value and then terminates, tends to be more fixed in size. So random number generator. This is a game changer for us in what it is we're going to program this year. And it also is a game changer for the games that you play. Random number generation is a really powerful tool, and I think you'll find this to make your programs a little bit more fun and interactive, because we can apply this in so many different ways. So a random number generation is a process in which, through a device, and we'll use the computer, generates a sequence of numbers that can't otherwise be reasonably predicted better than by chance. And we know from our statistics lessons in math class, it's really hard to randomly generate a number. There always tends to be a bias in there. Even if I asked you to guess a number, you tend to be biased on the number that you choose, or you'll put a bias into how that number is chosen based on your past experience. But good random generation needs to be executed without that sense of bias. So random number generators have applications in gambling, statistical sampling, computer simulation, cryptography, completely randomized design, and other areas where producing an unpredictable result is desired. And especially the games that you play. RNG is really used rather heavily in the games that you create. We use it a lot in cryptography for encrypting and decrypting information for the sake of, you know, hiding information or even transferring information over a network. So oftentimes basic RNG is based on a CPU timer, which is how we will engage it in our programs. We have a keyword randomized timer that ensures that each time I call to create a random number, it will pull on a random value from the computer's timing device. And we will also then use RND. That's what actually produces the random number from the computer. Now, RND, the keyword RND, produces a number from 0 to less than 1. And so it will produce any decimal value from 0 inclusive to the exclusive 1, so 0 to less than 1, any number. So it says let x equal RND, it will print x is equal to, so the random number that is generated from the system would be this 0.345243. I can also put it in a loop. I had my looping structure go from 1 to 5, and it printed for me 5 random numbers. And so we can see 5 random numbers that were generated. Now, what's interesting about this one right here is, take a look, it's in scientific notation. So this one actually produced a 0. So we're going to move him over 1, 2, 3. So this actually was this number that was produced, but that idea with having a whole number out in the front, or not having the zeros out in front, is what forced the scientific notation. Now, what I have not given you is the algorithm to produce whole numbers from here, which we will do in class, because this is how we generate a dice roll on the computer, is that ability to produce a number from 1 to 6. Or flipping a coin. So the idea of getting a value of a 0 or 1 or 1 or 2 to represent that heads or tails. And that we'll talk about in class as it relates to the math to create a random number. But we will use, in that random generation, we will also use our final function, the int function. And what the int function does is it accepts a number value as a parameter and returns the whole number portion of a decimal value. So it will always truncate the value, cut it off. It doesn't round it. It literally just cuts it off. So for example, I let x equal the integer value of 3.14159. It actually cut it off. And so it let x equal 3. So even if I had a y equal the integer value of, let's say, 6.7432, then y is going to equal 6. So it doesn't round up or round down. It just cuts, it literally cuts off the decimal portion of the value. And we will use this to create number sets of values in order to produce our random numbers.